Hey there, welcome back to the channel. Thank you for tuning in today. In our last video, we started looking at the main parts of a gas turbine engine. We looked at the engine intake and we also looked at the compressor of a gas turbine engine. If you haven't watched this video, you can find the link to this video in the description below. In this video, we continue with the parts of a gas turbine engine, and we're going to look at the combustion chamber of a gas turbine engine. We look at the turbine of a gas turbine engine, and finally, we look at the exhaust of a gas turbine engine. So welcome and enjoy the video. The combustion chamber of a gas turbine engine is where combustion in a gas turbine engine takes place. After the mass of air is compressed from the compressor, it flows to the combustion chamber. In the combustion chamber, fuel is added to the compressed mass of air and an ignition occurs to light up the fuel-air mixture in the combustion chamber. This ignition causes an increase in temperature significantly inside a combustion chamber. The combustion chamber of a gas turbine engine is located after the compressor and just before the turbine. There are three types of combustion chamber. One, there is the annular type combustion chamber. Second, there is a annular type combustion chamber. And thirdly, there is a multiple can combustion chamber. The annular type combustion chamber is a cylindrical shaped annulus that is found just after the compressor. The entire space between the compressor and the turbine is made up of this cylindrical shaped annulus that is the combustion chamber. It's only a single chamber. The can annular type, we have a series of individual combustion chamber inside one annular, and these individual cans are interconnected by an interconnecting tube that propagates the heat inside this adjacent combustion chamber. Finally, the multiple can combustion chamber has a series of individual burner cans mounted around the periphery of a centrifugal type compressor. Note that on this type of engine, the compressor that is suitable to use is the centrifugal type compressor. This because it allows easy flow of the gases from the compressor to the individual combustion chamber around the periphery of the compressor. For modern aircraft engine, the combustion chamber that you are mostly going to find on the engine is this annular type combustion chamber. It is the one used for most gas turbine engine or for newer gas turbine engines. There's a provision for the installation of the fuel nozzle around the surface of the combustion chamber. There's also a provision of the igniter plug in the combustion chamber. On most aircraft, we have two igniter plugs used, and they are installed at the 4 o'clock and the 8 o'clock position of a gas turbine engine. And these igniters provide ignition to the fuel-air mixture inside the combustion chamber, and this ignition is spread for the multiple can and the can annular combustion chamber type through an interconnecting tube that interconnects all the individual burner cans or combustion chamber. So this interconnecting tube propagates the ignition to light up all the adjacent combustion chamber around the periphery of the engine. Next, we are going to look at the turbine. Now, this is where the energy from the burnt gases is derived or is extracted, and this energy is used to drive the compressor and the accessories of the engine. About 70% of the energy generated by the engine is extracted at this point to drive the compressor and the accessories. Basically, the function of the turbine is to convert the high velocity of the gases, or the velocity of the gases into mechanical energy that is used to drive the compressor and the accessory. So that is the main function of the turbine or gas turbine engine: extraction of the energy to drive the compressor and the accessory gearbox. The turbine is located just after the combustion chamber and just before the exhaust section of the gas turbine engine. There are two types of turbines of a gas turbine engine. On some engine you can find an axial type turbine, and on some other engine you can find a radial type turbine. A radial type turbine is used mostly on APUs and old engines. In modern engines, the type of turbine used is the axial type turbine engine. The turbine is made up of vanes and rotor to make a stage of a turbine. As the burnt gases flow from the combustion section, they enter the turbine through the turbine inlet vane, or through the turbine inlet guide vane. And it is at this point that the temperature of the gases in the entire engine is the highest. At this point, at the turbine inlet guide vane is where the temperature of the burnt gases is highest as it enters the turbine. The turbine inlet guide vane and the turbine rotor makes up one stage of the turbine. From there, the gases flow again in the second stage, or the adjacent stage of the turbine, which is made up of again a guide vane and a rotor. At the turbine outlet is where the velocity of the gases is highest. So at the turbine inlet, the temperature of the gases is highest, but at the outlet of the turbine, the velocity is the highest. This is because the shape between the guide vanes and the rotor forms or makes up a convergent duct, and as the gases flow from the nozzle to the rotor, again to the nozzle to the rotor, the velocity of the gases keeps on increasing as the pressure is reduced, as the energy is being extracted from the gases. And by the time this gas reaches the outlet of the turbine, the velocity is the highest at this point, just before the gases is allowed to flow to the exhaust portion of the gas turbine engine. There are three types of blades that can be found on a rotor of a gas turbine engine in the turbine section. The first one is the impulse type of blade. This impulse type of blade forms a shape of a bucket, and as the gas hits the bucket, as it flows inside the turbine, this impact creates a motion or imparts a force on the blade, and this causes the turbine to rotate during operation of a gas turbine engine. This type of blade attachment is called an impulse type blade design of a turbine engine. The next type of the blade design is called a reaction. A reaction is shaped in a form of an aerofoil, and as the burnt gases flow across or over the blade, an aerodynamic force is created that drives or rotates the turbine, and thereby providing the force needed to drive the compressor. So this is the second type. Finally, there is an impulse reaction type of blade attachment. This type combines the shape of an impulse blade type at the root and an aerofoil shape type at the top. So this type of blade is tapered, whereby at the root up to midpoint is type of an impact type, and as you go towards the tip of the blade, we have an aerofoil shape, which forms which is the reaction portion of the blade. And this type of construction or design uses both the impact and the aerodynamic force in rotating the turbine of a gas turbine engine. Finally, we go to the exhaust portion of a gas turbine engine. The exhaust portion is the portion located at the rear of the gas turbine engine just after the turbine. The function of the exhaust is to straighten the burnt gases as they flow outside of the engine, and this has an effect of producing thrust of the engine. It straightens and accelerates the air or the burnt gases as they flow out of the engine, and this has the function of producing some thrust. Parts of the exhaust of a gas turbine engine are as follows. There is one tailpipe or an exhaust pipe. There is a exhaust cone, and lastly there is the exhaust nozzle, which is located at the end of the tailpipe. The passage between the tailpipe and the cone forms a shape that can be either convergent or divergent depending on the type of the engine, and this can cause acceleration of the gases as they leave the engine, and this has the effect of producing thrust on the gas turbine engine. For supersonic aircraft, the shape of the exhaust is a convergent divergent shape. For subsonic aircraft, the shape can be either convergent or divergent, and this is, like I've said, is formed between the tailpipe and the cone of the exhaust of a gas turbine engine. The nozzle of the gas turbine engine is a very critical part because its shape plays a very crucial role in the exhaust of the engine. One, if this exhaust nozzle is too big, the aircraft or the engine can experience a loss of thrust if the nozzle is very big. And if the nozzle is very small, the engine can choke or even stall. So this is a very carefully designed portion of the gas turbine engine, as it plays a major role or a critical role in the production of thrust and the operation of the entire engine. The material that is used the most in making the exhaust of a gas turbine engine is stainless steel. This is because the stainless steel can withstand the high temperatures of the gases as they leave the gas turbine engine going outwards. Thank you for watching the video till the end. If you haven't subscribed to the channel, we kindly request you to subscribe to the channel and also to turn on notifications so that you'll be notified every time we post new videos. We value your time, and I hope you have an amazing day. I'll see you in the next video.